today we are going to talk about geometric series, so you will be able to identify, define, and find the sum of geometric series. First, what is a geometric series? A geometric series, just like an arithmetic series, is the sum of the terms of a geometric sequence. If we have our geometric sequence, we can then So the formula for the sum of the n terms in a geometric sequence is a sub 1, which is our first term, times 1 minus r to the nth power, all over 1 minus r. A sub 1 is our first term, r is our common ratio, and n is our number of terms. So when finding our geometric series, we need our first term, our number of terms, and the common ratio. Our first example is to find the sum of the geometric series. We should identify what information we need. So we need our first term, which is equal to negative 15. We need our number of terms, which is n. 1, 2, 3, 4, 5, 6 terms. And we need our common ratio. To get r, we take our second term and divide by our first term. So we have 30 divided by negative 15, which is equal to negative 2. We can then use our formula. The sum of the first 6 terms is equal to our first term, negative 15, times 1 minus r, which is negative 2, to the nth power, which is 6, divided by 1 minus r. Put this in your calculator. So the sum of our first 6 terms is equal to negative 189. An infinite geometric series with a first term a sub 1 and a common ratio, whose absolute value is less than 1, has a finite sum. The reason behind this is because we are multiplying by a fraction or a decimal that is then going to be approaching 1 value. So to find the sum, s is equal to a sub 1 over 1 minus r. The infinite geometric series with the absolute value of r greater than or equal to 1 does not have a sum. So if r is greater than or equal to 1, we do not have a sum. To say that an infinite series a sub 1 plus a sub 2 plus a sub 3 and so on has a sum means that the sequence of a partial sums. So, if we have sum 1 is equal to term 1, sum 2 is equal to term 1 plus term 2, sum 3 is equal to term 1 plus term 2 plus term 3, and so on until we get to sum n is equal to term 1 plus term 2 all the way to term n, converges to a number s as n gets very large. When an infinite series does not converge to a sum, the series diverges. An infinite geometric series with r, the absolute value of r greater than or equal to 1, diverges. So here, does the series converge or diverge? If it converges, what is the sum? So first we need to find r. To find r, we take our second term, 1/2 divided by 1, which is equal to 1/2. So the absolute value of r, or the absolute value of 1/2, is less than 1, tells us we are going to converge to a number. So we're going to look at the formula. Here, s is equal to term 1 divided by 1 minus r. and apply it to this geometric sequence. So, S is equal to term 1, which is 1, divided by 1 minus R. We said R is 1/2. So we have our sum is equal to 1 divided by 1/2. So our sum is equal to 2.